Alright. 24th of March, 2026. I'm doing this a bit late. I have to be a bit quiet as well because everyone should be asleep now. But I forgot to do the problem, so I'm going to do it now. Alright, so 2906, construct the product matrix. Let's get this one open. Okay, should be good. Okay, so given a zero indexed 2D integer matrix grid of size, what the heck, of size n by m, we define a zero indexed 2D matrix P of size n by m as the product of the matrix grid. What? As the product matrix of grid, right? Sorry. So we define zero indexed 2D matrix P of size n by m as the product matrix of grid if the following conditions is met. If the following condition is met, each element of Pij is calculated as the product of all elements in grid except for the element ij. This product is taken to the modulo of 1, 2, 3, 4, 5. Return the product matrix. Okay, so if I take this as an example, I'm assuming, okay, I'll just guess what they're saying first and then look at what they're saying. So, example, if the original matrix is 1, 2, 3, 4, then the product matrix would be, in this corner, you take the product of everything except that first value. So it would be 2 times 3 times 4, which is 12, 24. And then the product, like the value over here, would be the product of everything except the 2. So 12. Product of this one would be 8. And the product over here would be everything except the 4, which is 6. So that's my understanding of what 24, 12, 8, and 6. Okay. So, okay. So my understanding is conceptually, what you could do is find the entire product. So, like, conceptually, what you could do is find product of all values in the matrix, and then basically for each position ij, the P matrix at ij, we'll call this product X. So the product of absolutely everything, we'll call it X. The product at ij would be X divided by grid at ij. Now, I'm assuming the reason why this wouldn't work is because each value can be a billion. So the product you get could be like, a gazillion, basically. And if you get a gazillion in standard programming languages, you would have problems, right? In terms of space problems. It wouldn't fit in an integer or a long whatever. Now, because it's Python, you might get away with it to some extent, but I'm imagining that you're supposed to sort of, the spirit of the question is to try to use the modulo throughout the question. So my basic thinking is, if you have A, B, mod M, I think, wait, I'm a bit nervous because I don't know if I remember my modulo things very well. So, considering we're in mod 1, 2, 3, 4, 5, right? Which isn't prime, which might be a problem. If I'm gonna do like, A, B, C, D, and then divide that by D, and then take that mod 1, 2, 3, 4, 5, right? Like that's basically what the like A, B, C, D are the 4 elements in the matrix, and I'm going to divide by D for one of the elements, and then to the mod. I think, is it fair that to say that that's the same thing as A, B, C, D times D to the negative 1, where D to the negative 1 refers to the inverse of D in mod 1, 2, 3, 4, 5. And then if that's the case, is it fair to say that it's the same as A mod 1, 2, 3, 4, 5 times B mod 1, 2, 3, 4, 5 times C mod 1, 2, 3, 4, 5? So we can kind of like, I think this is legal. I'm not actually sure. My basic goal is to find the inverses of each element in the matrix for this modulus, and then pray that this is fair enough. And then instead of D, we can just say times 1, because D times the D inverse gives me 1 in mod 1, 2, 3, 4, 5. Now finding the inverse, is an inverse always guaranteed? Probably not, right? What's Euler's theorem? It's like A to the phi of n is congruent to A mod m. Is that correct? Does that mean A to the phi of n minus 1 is equal to 1, congruent to 1 mod m? Which means this thing is the inverse of A? No. Wait, what? Wait, no. If this is congruent to 1, then A times A to the phi of n minus 2 is congruent to 1, I think. So I think this is the inverse of A. Maybe. Should I first just try the naive approach? Full product is equal to 1 for so num rows equals the length of grid, num cols is equal to the length of grid at 0, and I'm assuming we have at least 1. Yep, good. So for R in in range num rows, for C in range num cols, full product times equals the matrix at RC, and then do I have to, can I just do it in place? So like for R in range num rows, for C in range num cols, grid at RC is equal to the full product floor divided by the current value at RC. So I think conceptually this would work, if not for the limitations of computers generally. Oh. Whoops. Wait, what? Oh, because of the modulus? I forgot about that. Mod equals 1, 2, 3, 4, 5. This thing, mod. Sorry, that shouldn't be out there. Put that in there. Yeah, so like conceptually it would make sense. However, I think that's a bit dumb. So there's a couple of things we could do. I think a good pre-processing step would be actually to reduce RC mod equals the mod. Like, just make it so that, you know, if someone puts 1, 2, 3, 4, 5, that's basically the same thing as just putting a 0 in this world of 1, 2, 3, 4, 5. So I think that's a good idea. You know, that way our numbers we guarantee are between 0 and 1, 2, 3, 4, 4. And I'm assuming the values are between 1. Okay, so this is not 0, which is good. Oh, this isn't negative, which is good. I just don't know if this inverse thing actually works, so I don't remember. Like, I learned about this stuff in math, but it's been a bit of time. These rules, finite math, discrete math, I learned them, but it's been a minute. A, B, C, D. Dividing by D is the same thing as multiplying by the inverse when you're looking at modular arithmetic. So I mean, I think it makes sense. And that way, the idea is that way you're always handling, like, you know, at most you're going to be multiplying by 1, 2, 3, 4, 4, multiplied by 1, 2, 3, 4, 4, which is 1, 2, 3, 4, 4 squared, which is like 150 million, which is fine. Like, you're not near a billion yet. 1, 2, 3, 4, 5, 6, 7, 8, right? 8 zeros, not 9. So which is completely fine. And then you mod it with 1, 2, 3, 4, 5, and that will bring you back down to something between 0 and 1, 2, 3, 4, 4, right? So, like, if you do this, then I think the idea is you never get to, you never have to deal with, like, integer overflow, basically. So I think this is the right idea. So reduce it down, and maybe I want a separate. Maybe I want to create a separate array, like inverses, which is so for in range numcols. I should put C for R in range numRows, and I want to basically self.get inverse of a particular value R and C. I guess I could do this within the double for loop here as well, but it's okay. I'll just do this comprehension. So getting the inverse, this is where like the math comes in. Get inverse of a particular value, given that, so assuming the mod is 1, 2, 3, 4, 5. I'm not going to bother like parameterizing or anything. So if this is correct and the inverse is a to the 5n minus 2, God, I hope this is right. The power is really dodgy. So what is 5n? 5n refers to 1, 2, 3, 4, 5, right? So I think the idea is you're meant to decompose it into its primes. So divided by 5, so it's 5 times 2469, which is divisible by 3, so 2469, right? If I multiply by 5, I get, whoa, wait, what? 2 4s, wait, what happened? 2 4s, sorry. 2469 divided by 3, divided by, I don't know, 7? Nope. Divided by 3, so you got a times 3 in there. And then 10, so it's not divisible by 3 again, 823 divided by 11? No. No, that's not prime. 13? No. 17? Am I missing an obvious one? I tried 7, yeah. Not 5, not 3, because 13, 5, 7 I tried, 9 I tried, 11 wouldn't work anyway. 13 did I try? 15, 17 I think I tried, 19, 23. I'm getting pretty close. 23, 20, nope, that's not prime. Is 823 prime? Well, I mean, I think I tried all the numbers smaller than the square root. Square root of 823 is 28.6. Okay, so I think, I'll double check, is 823 prime. I guess it looks pretty prime. Oh, there you go. Well, so 823. So again, 823 times 5 times 3 is 1, 2, 3, 4, 5. Cool. So it's the phi of this, which is equal to 822 times 4 times 2. 822 times 4 times 2. 6576. 6576. Ah, this is quite a big number. So is this not gonna work? Ah, I thought I was very clever, but maybe I'm not. Phi of n is congruent to a mod, which means if I multiply both sides by the inverse, a to the minus 1 times a phi of n is congruent to 1 mod n. That is to say, a to the phi n minus 1 is congruent to 1, so a times a to the phi n minus 2 is... So if I want to get like big powers of a, because if phi of n is that, then what I'm really looking for, this is my inverse, what I'm really looking for is a to the power of 6, 5, 7, 4, right? Because minus 2. So I'm trying to calculate that. Mod n. That feels like it's stupid. I mean, I could do it a bunch of times, but I don't think that makes sense. I guess I have the computing power, but I don't think I should have to. Like, this feels like a lot of operations for one value, you know? Maybe I'll have a hash table as well. Cached self.cached inverses equals nothing. What was like? I remember there's a technique to do this kind of thing, but do I have to do it every time? Is there a way to like decompose it a little bit? 6574. I can't tell if it's meant to be just straight up math or if I'm like missing something obvious. A to the 6574 mod n. Like, I remember you can make like a table, like, you know, a to the 1 is equal to a squared is equal to a squared, a cubed is equal to, and then like the idea was, oh, maybe that could work. Wait, what? How can I decompose 6574? 6574 divided by like 2, 3278. So 6574 is 3278, right? 87, sorry. So 6574 is equal to that times 2 is equal to 2 times 3287. That's not divisible by... I'll just Google it. 3287 factors. 19 times 173. That's not great. 19 times 173. So a to the 6 is the same thing as a to the 2 times 19 times 173. So now I only have to get up to here. I have to find this power now. Is there a thing where like it cycles along or something? Like it does, like it repeats in a cycle? I forget. Is that predictable? Do I know that's gonna happen? Is it like after some number of times the powers of A will like cycle back when you're in mod n? Do I know that? Alright, I think I'll just do this. So if val is in self.cached inverse, then return self.cached inverse at val. Otherwise, result is equal to 1 for so I have three things. So necessary values is equal to, so val power of 2 is equal to none. Val power of 19 73 is equal to none, and my counter is equal to 0 or something, or 1. Result is equal to val counter while counter is less than 2, result equals result times val whole thing mod. I guess I will do self.mod. Right? And then val pow 2 is equal to result counter increments while counter is less than 19, result same thing, and then val pow of 19 is equal to result, and while counter is less than 173, same stuff, and then val pow 173 is equal to result, and then my answer, or what I need to return, I think, my understanding is I'm trying to get a to the power of this, and... Oh, wait! Oh, bro, I'm an idiot. I thought I forgot how index laws work. Oh my god. Alright, screw it. We'll just do this. I was trying to be really clever, but it didn't work. For in range 6574, val is equal to answer is equal to answer times val mod self.mod. So I'm calculating this guy, so answer has to start at 1. So after one iteration you get just val, and then after 2 iterations you get val squared, val cubed. Val is like the a, by the way. And then eventually, I should say self.cached inverse at val should equal answer, and then return answer, I guess. So then we get the inverse of everything, which is cool. And then so we get the full product, which is like you multiply on this and you also reduce the full product grid RC, so you reduce it down, you multiply the full product, and then you also reduce the full product down. You get the inverses of all the values, which is my most expensive thing, I think. But if I am lucky, then my result is the full product multiplied by the inverses at RC as well. So you take the full product, multiply by the inverse of whatever's here, and that's meant to basically be the equivalent of dividing, and then you also just make sure to mod it again. Does this work at all? Whoops. Line 38, maybe 37 now. Whoops. Big whoops. That should be better now, I think. Oh. Well, that didn't work at all. This could be completely wrong. Like, I'm kind of half guessing, to be honest. Let me print the inverses just to see what happened. Because, like, 9529, so like 2 times 9529 divided by 1, 2, 3, 4, 5. That's not a remainder of 1, there's no way. I don't think my inverse thing made any sense. So is this not the inverse, or? Is this wrong? A to the 5n is congruent to A? Euler's theorem. Oh, a to the 5n is equal to 1. Oh, so the inverse is a to the 5. So it's, sorry, I got this wrong. So that means, okay, wait. Let me try this again. One more time. A to the 5n is congruent to 1 mod n. See, I try to use my memory and look what happens. Which means a times a to the 5n minus 1 is congruent to 1. So a times in mod n. So in the context of n equals 1, 2, 3, 4, 5, knowing that 5n, do I have it? 5n is equal to 6576. So a times a to the 6576 minus 1 is congruent to 1 mod 1, 2, 3, 4, 5. So the inverse of a is equal to this guy, 6574, a to that. No, sorry, 5. What? How did that even happen? The a inverse is equal to that guy, 5 at the end. So let me try that. Damn, it was like one extra iteration. Any luck? Oh. Hey, like, kinda worked. This one was good. Don't know what happened to this guy, though. How did... Okay. Wait, let me look at this. So, this is the inverse. Because I'm printing the inverse, right? Yeah. So the inverse of 3, apparently, is this guy. Times 3 divided by 1, 2, 3, 4, 5. Yeah, I don't think that worked. That's definitely not a remainder of 1. 0.33 is like a third of this guy. That's the remainder, I think. Man. I really thought I had it. I thought I was clever, but it didn't work. This is kind of funny. What happened to the other one? Was it similar and like, ooh. Oh, that's interesting. Because it's reduced to mod, 0, the product ended up becoming 0 completely. So how would you even bother handling that? Because like the inverse of 0 isn't really a thing. Like you can't reverse a 0 multiplying by 0 in this kind of context, because you're basically trying to like multiplying by the inverse of 0. Like what are you multiplying by 0 to get 1? That doesn't really make sense. 6. Well, I guess what I could do is I could have like a 0 count, you know? This is a bit of a hack, but if grid at RC is equal to is equal to 0, then 0 count plus equals 1. Now if the 0 count is exactly equal to 1, then just don't do the multiplication, basically, is what I would say. And so yeah, if val is equal to 0, then I think returning 1 basically means like you're not going to change the product, which is kind of what I want. If 0 counts equal to 1, then that's fine. We'll just won't bother. If 0 counts equal to 0, then do all this stuff, like that's fine. If 0 count is equal to 2, then like that means all the elements are gonna have a 0 multiplied to it. Greater than, I'm gonna return anyway. Return 0 for in range numCols, for in range numRows. I think that's fine. I wonder if this would work now, because I'm just returning 1. Oh, I did right. What? Oh, because it is 0 still. If 0 count is equal to 1, what do I want? Like if this is the first 0 I saw, I want the product. I need the product to show that it's 0 for like everything except full product, 0 product, without 0 product. So if there's no zeros, then I think without 0 product could just be the full product. But if the 0 count is equal to 1, then the without 0 product the full product should be set to 0, because, you know, the product is 0, but the without 0 product should have the grid RC multiplied to it, or 1 multiplied to it. So if this thing is a 0, then just multiply 1, but if it's bigger than 1, then multiply it properly. Yeah. So now, if grid at RC is equal to 0, then, like, if this is the point where there's a 0, then we're going to have to use grid at RC is equal to the without 0 product. There's no real division required because we never bothered multiplying by the 0. Self.mod. Else, I think this would be fine. So I tried to sort of hack my way through it using a counter. Okay, so that kind of behaves as I want. But this didn't work, which is a big shame. 1, 2, 3, 4. 1, 6, 1, 7, 3. Sorry. So what would the inverse of 3 be, just to clarify? The inverse of 3 in mod 1, 2, 3, 4, 5. Wasn't there like an algorithm to finding inverses? I could have sworn. Oh, wait. Wait a minute. I think I remember it. Okay, so there's this phi of n thing. I think there's something else. If I do... Oh, but I think it's... Oh, I remember. There only exists an inverse if the GCD is 1, right? Is that true? So like 1, 2, 3, 4, 5. 5 plus... Like that's divisible, that's divisible by 3, right? So there's a problem. Because you can't write sort of 3x plus 1, 2, 3, 4, 5, y equals 1. This is impossible to write for integers x and y. Because when you do the Euclidean algorithm or whatever, to get like the GCD, you'll get like 3, and then you won't be able to rearrange the equations to make 1 equal this thing. So there is no inverse. So what the heck am I meant to do? What? But then Euler's theorem says this. So then, like, why does it fail? Like, it feels like they aren't saying the same thing. There only exists... In mod n, does an inverse of A only exist if GCD of A and n equals 1? Yeah, so this thing, like, you try to write it in the form of ax plus ny, but so then how does this... Oh, I get it, I think. Because, you know what it is? When you write this... No, I don't get it. Yeah, I think I do get it. Okay, the reason why this fails, like, in my mind, this made a lot of sense, right? A to the phi of n is equal to 1. It's congruent to 1, mod m. So a to the phi of n minus 1, no, sorry, a to the phi of n minus 1 times a is also congruent to 1. So this should be the inverse of a, because multiplying a by this thing gives you 1. But I think I think this is illegal. Because when you say phi to the n minus 1, you're basically multiplying a of phi to the n by the inverse. You know what I mean? which I don't think really makes sense if an inverse doesn't exist to begin with. So it's kind of like a visual trick. If that's the case, I really don't know what to do. Like the fact that 1, 2, 3, 4, 5 specifically multiplies with by 5, by 3, and by other stuff. Wait, prime factorization of 1, 2, 3, 4, 5. Obviously there's a 5 in there. 3, 5, 8, 2, 3. So like if those numbers are in the product, I am not very confident that I know what to do. Would it be such a bad idea? Maybe I can just divide. Maybe I don't have to. Because like, if I'm really confused. No, but if I'm doing mod operations throughout the original product multiplication thing, I don't think I can afford to. Hang on, in my original solution. Okay, sorry, I thought I was dividing by 0 in like the original solution, but I don't think I am anymore. So yeah, so the reason 3 fails is because the inverse doesn't exist. It would be this, like, if I change that to like a 4, if I change that to like a 7, because an inverse would exist, it would be fine. I imagine. But if I change it to 384, which was one of the factors, right? 823. If I change it to 823, then I think it will fail again. Okay, see, some of it's starting to come back to me now. But I'm curious, so like, I can't just do modular stuff throughout? Like, if I'm at risk of there being an 823? Or a 3 or a 5? Like, you know what I mean? Like, it's very strange. Maybe I have to check those things separately somehow? Okay, so I have inverses for most of the things. But if there's a 3, or if there's a 5, or if there's an 800 and whatever, 23, then I have to first... What do I do? Like, how do I actively get rid of the 823 from the original? Unless I do something similar, like, you know how I said, unless I said, like, you know how I said, like, oh, if there's a 0 or whatever, maybe I have to, like, keep track of the number of... Oh, that's so silly, though. Oh, and like, the thing is, it's not just 5, 3, like, any number that has these factors, so 25 as well would fail, and like 15 would fail, wouldn't it? Because the GCD was still not 1. So like, it's not just a matter of like, oh, we're looking for 5s and 3s, it's like any number. So this is completely like, every third or fifth number, every third number basically, will have a problem, which is like a lot of the numbers. I'm really not sure what to do then. So if inverses aren't reliable, then how can you confidently remove a particular value? Okay, so I can find the inverses of anything that isn't, you know, divisible by 3, 5, or 800 and... Sorry, it doesn't have a It's not even about divisibility. Because, like... Wait, is it? No, it is. If it's divisible by one of these 3 things, then you know that the GCD of... Yeah. So I can detect when the inverse thing is not going to work. And so if it's not going to work, what do I do instead? I can take the... I can, like... I can take the product with the 3, for example, and then the product without the 3. What am I missing? I must be missing something. Either I'm missing like a trick, or I'm like, I don't know, maybe this modulus thing idea was not good at all. I'm sleepy now. I don't know. If the GCD is not 1, then there can't be an inverse. So how do I make sure that I successfully remove that factor? Like division in modular arithmetic is weird, that's the issue. Always a bit of a red flag doing division when modular arithmetic is involved. Wait. There is a thing though, right? When you divide by a number in a particular modulus, and you're dividing. Wait. I don't know if this works, but it might work. Okay, I have a new plan. Screw the inverses. This is again me pulling like from the deep recesses of my mind. I think there's a thing where. Okay. Get rid of all of this. I think there's a thing where it's like, if you have like some x mod, if you have some x, wait, what? Mod k, and you want to divide by 5. Does that mean it's like that result x over 5? It's equal to x over 5, but you like have to divide the modulus as well or something? Like assuming 5 goes into k, then this is true? Like, is this a thing when you're doing division in modulus? I think it's like when you have congruency, like x is congruent to y mod k, that implies that x over 5 is congruent to y over 5 mod k over 5, assuming that 5 goes into k cleanly. But like, then you probably would expect the x and the y to also be divisible by 5, which I'm a bit concerned. Like, if you have like, if you multiply by a number that's like, if you multiply by 1, 2, 3, 4, 6, right? Then the result should be divisible by 2, for example, right? Like, whatever the product is that you get should be divisible by 2. But in the modulus, this is the same thing as multiplying by 1, which isn't going to make something divisible by 2, you know what I mean? So like, the things that you can divide by if you multiply by the original number is not going to be the same as the things you divide by if you reduce by the modulus first. That's why I don't get what I'm meant to do, because if I do this modulus thing, then how am I meant to know what I'm allowed to divide by and stuff? Do I cheat? Alright, should I just try submitting the brute force thing? Just leveraging the fact that Python will be fine. Alright. Product is equal to so I don't know this. Times equals this guy, and then I really could just say return for C in range numcols for R in range numrows, and then you say something like full product divided by grid at RC, whole thing modded with self.mod. Don't need any of this. Don't really need this either. Don't really need this. And if I did self.mod, oh, whoops. Why is it? Oh, it's green because of the integer. I mean, if this works, fine, but it's not like, it's not what it's meant to, it's not what you're meant to do, you know? Ooh, a bit slow. Space issues. Fair enough. So they did make sure that they want to make sure that you didn't just cheat, basically. Ooh. I don't know. I just don't know how to not, like, how to get rid of a number if not dividing, and I can't rely on the inverse thing. I mean, I'm assuming the mod is important, like in terms of like you're meant to do some kind of math with the modulus, but maybe you're not. Let's take a hint. Okay, thank you. Create 2D arrays for suffix and prefix product, and use them to find the product for each position. What? Create 2D arrays for suffix and prefix product, and use them to find the product for each position. And use them to find the product for each position. Okay, so like, if I have an example like that, and they have the elements inside. Prefix, suffix. So this value, for example, the prefix is like, what is the prefix for 2D arrays? What does it mean? Like, in what direction do you go in? Create 2D arrays for prefix and suffix product. Maybe that's what they, no, wait, what? Go across like that, maybe? And it's like, what is, you get like the cumulative thing? Oh, so to get this value, you multiply this guy by this guy, the suffix of this guy. Oh, I think that does make sense. That way you never actually introduce him at all. That's quite clever. Okay, big cheat, I can't lie, but fair enough. Okay. So like so prefix equals, damn, I'm a bit sad I didn't think of that, but fair enough. We'll say 1 for in range R, sorry, C, I mean numcols, in range, I feel like I could have got that. I don't know, I think I tunnel visioned, let's be real, that's what happened. So for R in range num rows, for C in range num cols. So if R is equal to 0 and C is equal to 0, so base case would be, so prefix at 0, 0 is equal to grid at 0, 0, and suffix at last row, last column is equal to grid, last row, last column. If R equals to then just continue. Otherwise, if C, if we're not like, if C is equal to 0, then previous product is equal to prefix at previous row and the numcols minus 1, and then prefix at the current row, current column is equal to the previous product times the current value with the mod. Else, if we're not in the this very first column, then previous product is simply prefix at the same row, but the previous column, and then same kind of thing over here. In fact, I can say previous product equals 1, get rid of all that, and then do that here. Previous product is equal to this one, also previous product is equal to this one, and then get that guy, and similar idea for R in range num rows minus 1 down to -1 decrement, for C in range num cols minus 1 down to -1 with the decrement. If we're at the very last, if R is equal to num rows minus 1 and C is equal to num cols minus 1, then we can continue because we've already set that. Otherwise, what am I trying to do? So like going across like this, right? Sorry, so yeah, going across like this. So like if I wanted, let's say this particular value, so if I'm on the end column, if C is equal to num cols minus 1, as opposed to C equals 0, in the previous product, is equal to prefix, is equal to suffix plus 1, 0, because the previous is over here. Else, the previous product, if you're in any other column, the previous product is 1 to the right. It's equal to suffix at the same R, but 1 to the right. Previous product is equal to 1 again, just to give it something. And then similar idea here. Suffix at RC is equal to that guy. Okay. That's probably why they made the mod 1, 2, 3, 4, 5, like putting factors in there so that the inverse thing wouldn't work. But I forgot how inverses worked. So I thought I was a big man. Else do that. Okay, so we should have everything set up, and then basically, how do I do this? Do I do it? I guess I could do it in place. Grid at 0, 0 is equal to suffix at. Oh, but what if there can be one column? I was gonna say like grid at 0, 0 is like one across, but that's not necessarily true. I know what I want to do. It's like for each value, you take like the guy next to them. So this, you take this from the prefix, you take this from the suffix, you multiply them and do the mod. I know what I want to do. It's just there's some weird edge cases. So like if you're over here, there's no guy before you. You just need to guide the guy after you. So 4 are in range numbers. 4 C in range num-calls. If R equals 0 and C equals 0, right? So if I'm at the very start, then I've only got one thing to look at. I've got to look at the suffix. If num-calls is equal to 1, then grid at RC, I'm doing this in place, grid at RC is just equal to suffix at okay. Okay, I'm going to deal with the 1 by 1 case separately. Deal with the 1 by 1 case separately, because I feel like this is going to mess this up. So if the number of calls is at 1 and we're at the very top left corner, then I need to take the suffix of row 1, column 0. Else, grid at RC is equal to suffix at row 0, column 1. Okay. Elif R is equal to numbers minus 1 and C is equal to num-calls minus 1. Then if num-calls is equal to 1, then grid at RC is equal to suffix at so at the very bottom, and there's one column, so I need to go one more row up. So numbers minus 2 and then column 0, because there's one column. Else I need to go, so if I'm over here, that's what this is saying. If I'm over here, then I need to, wait, did I say suffix or prefix? Let's just say prefix now. Looking at the prefix. Prefix needs to be same row numbers minus 1, and the column would be C minus 1, num-calls minus 2. Same row, but one position back in prefix. Okay, so that's if we're like, those are like the weird cases. Else, if numCols is equal to 1, oh my god, there's actually so many weird cases. Like, what if you're over here? Then, like, you know what I mean? Like, you gotta look over there for prefix, and you gotta look over there. And if you're over there, then you gotta look. If numCols is equal to 1, then grid RC is equal to, so you gotta look 1 above at prefix, you gotta look at R minus 1 C times prefix R plus 1, I guess it would be 0. Mod self dot mod elif you're in like the 0th column, so you're over here, then this thing is equal to, so at prefix you have to go 1 row above and then numCols minus 1. Oh, this would track for this anyway. This would work. This case would work here anyway. Okay. And then for this, it would be same row. See at column 1. I guess they should say suffix. I should this. I guess this changed from this because it's different row versus same row. Elif C is equal to numCols minus 1, grid at RC is equal to, it'd be the prefix at the same row and C minus 1, numCols minus 2, times the suffix at the next row over, column 0, mod self.mod. And then finally, the general case, grid at RC is prefix, same row, previous column, times suffix, same row, next column, mod self.mod. I think I've dealt with all the cases, all the weird little cases. And then we return grid. Way too many lines, but it's fine. I deal with, okay, so if, sorry, I don't need this then, do I? If numRows is equal to 1 and numCols is also equal to 1, what should I do? Does it say specifically what to do? Let's find out. Return, I would think like 0 or something. Like, what's the product without this number here? You know? But wait, not return 0, you donkey. It needs to be an array. Check that grid. Wait, what? Oh, the value of this should be negative. Should be at least 1, but the number of elements should be at least 2. What? Oh, it has to be a 2 by 2. No. What? Check that 2 is less than or equal to grid length times. Didn't I do that? Oh no, wait, I'm dumb. Okay, this case isn't gonna exist, but I meant to change the test case, but I just changed my code. It is 1 AM. Alright, I think I back it, basically. I mean, there are more cases. I should have checked 1 column, but it's fine. Oofed. Wait, what? Did I not mod everything? Oh, whoopsies. self.mod. Wait, no, wait. Did I not? This, I shouldn't have to. Prefix should already have done this. Huh? Ooh. Was it because of this? This kind of thing. Oops. Like, prefix should always contain a modded thing. So I shouldn't have to mod again. I mean, I can, I guess. But it's an extra operation. I don't think I should. Like, if it's just a one prefix value by itself without any multiplication. Like here, because I'm multiplying, I might need to self-mod again. But before then, I don't think I should have to. But it would make sense that it messed up because this would have done 1, 2, 3, 4, 5 like in the original prefix. It wouldn't have changed it. Where's the play button? Oh, there it is. Okay, hang on. Let me try one column real quick. So okay, one column. The one column stuff is sort of working. So hopefully I handled the case. Okay, fair enough. I'm annoyed though. I really feel like that was one I could have gotten, like prefix sum and stuff, or prefix product in this case. Suffix product, like, it wasn't that outrageous an idea, this idea of like, yeah, to get a particular value, think about all the product you've gotten up to here, think about all the product you got up to here, and like just take them, and you just will ignore this guy. I think I was really excited to try to do some modular arithmetic. I've been itching for it, so I thought I'd gotten it. I don't need this anymore. Don't need this. I'm assuming there's like a bit of overhead from like making random functions, random methods. Oh well, at least we got it, but yeah, I'm annoyed. I really feel like I could have done that first try if I had just not been silly. I didn't achieve anything. Anyway. Oh wow. Wait, did I not have to deal with all these cases randomly? P of ij equals suffix. Suffix equals suffix times... Oh, right. So you didn't have to make separate arrays at all. I just followed the hint, I suppose. Well, yeah, you could have just... Wait, no. How did you do that? Wait, what? So you did one for loop, and you went... So you have P, which is the answer you want to make. For I in range n minus 1, minus 1, minus 1. For j in range m minus... So you're going backwards. You're making the suffix thing. For j in range, this one, yeah. So going back through the column... No. Okay, so n is rows. So back through the rows, and then for each row back through the columns. P of ij is equal to suffix. Suffix is equal to suffix times grid of ij mod. Huh. Oh wow, yeah, wait, that does make sense. Because... Does it make sense? Wait, so going backwards through the array, you set P of ij to be equal to the suffix. So P of ij basically originally is the suffix, I think. And then, yeah, so P of I, yeah, I get it. So you make P of ij equal to the suffix, which is all the numbers multiplied together before this position, all the numbers, and then suffix equals suffix, and then you update the suffix by including this number. And then going forwards, yeah, this gets you the final value because it's the suffix stored at this point, which will be all the numbers before this position, but going backwards, of course. multiplied by the prefix, which is all the numbers going forwards before this position, and then you update prefix to have this position as well. Yeah, that's cool. That's clean. I just took the hint very literally, so but naturally, yeah. But I'm surprised that, yeah, because you don't have to worry about any positioning information because you're just updating a suffix value and a prefix value. Fair enough, and you let the for loops just handle it for you. I was very explicit because I'm not thinking very straight. Yeah, well, anyway.